Machine learning, specifically reinforcement training, is a method for training AI which involves rewarding the AI agent when it exhibits the correct behavior and punishing the agent when it exhibits the wrong behavior. Why is this relevant? Well, I'll tell you. You see, I just spent the last 4 weeks creating a small-scale machine learning model for an English project. So in this video, I'm going to go over the development process behind the AI, what I learned from it, and most importantly, how it relates to my English class. So why on earth did I create a machine learning algorithm for an English class? Simple answer, really. At the beginning of the semester, I wrote an essay on the increasing usage of AI in classrooms titled The Terminator vs. C-3PO. Now, I was quite proud of how this essay turned out, so when my professor outlined the final project, an open-ended, do whatever you want kind of project, I immediately knew I wanted to do something related to that fantastic essay. After slamming my head against a metaphorical wall for a while, I finally decided that the best approach to this project with the limited time I had to complete it was to spend 4 weeks learning how to create a machine learning model and then spend the last few days creating this video. Easy peasy lemon squeezy, right? No. In fact, at this point I'd say the lemons have been squeezing me. I think the process I went through to set up and create the AI agents can be likened more so to fist fighting a brick wall than programming. But that all comes later, much later. To be honest, this project started out simple enough. I decided the best way to approach it was to utilize Unity's ML Agents system, which I had stumbled upon by accident a few weeks prior. And when the time came to begin, I started by creating a new Unity project and followed this fantastic series of videos by Luddic Worlds to learn how to get started with ML Agents. These videos started out simple enough to follow, and pretty soon I made it through all 6 and was ready to begin working on my own project. Now, for my AI, I wanted to create something a little more complicated than the agent simply going to the target. Normally, a machine learning algorithm would be used for something useful such as reading handwriting, identifying animals, or recognizing drawings. The reason that machine learning is a good solution for these issues is that the machine would be able to correctly identify objects that are similar and then correctly classify them even if it had never seen that exact object before.
Cat. Cat.
But, for the sake of having a bit of fun, I wanted to train my AI to do a more physical task. And after careful consideration, I decided that an interesting challenge for the AI to solve would be pushing a block into a goal. I figured that this would pose enough of a challenge for the AI that it wouldn't learn how to complete the task immediately, but it wouldn't be too difficult so that it would never figure out how to solve the task. This would also properly demonstrate that my training actually works for a harder task, and maybe I learned something along the way. The first step was to create a new Unity project and design the scene. This was simple enough, honestly. I just used a very similar level layout to the learning project I had made. Except this time, I moved the goal object to the far side of the arena and added a new block for the AI to push. Now, all I had to do was program this new AI and it's all set to go. Should be easy enough, right? It wasn't. I was able to reuse a lot of the code I wrote for the learning project, but because I had added the block object, I needed to update the observations code to include the location of the block, as well as the goal and the agent's own rotation position. After that, I gave it a quick test, and the agent got negative infinity rewards every frame. Basically, if this was our example human, it would look like this. This happened because I had forgotten to set up the max step count, which meant that every episode was running for 0 steps, which confused the program, so I guess it took its anger out on the poor agents. It also turns out that I'd forgotten to give the agent any indication that moving the block was a good thing, so it never touched the block during the first attempt at training it. So I dove back into the codebase and added a small reward for the agent being near the block, and a small reward for moving the block closer to the goal. These 2 changes were designed to encourage the agents to move the block towards the goal without telling them to do so, because the agent still has to discover that standing near and moving the block is a good thing, but once it does, it should start to do that more and more, and eventually will accidentally move the block into the goal and realize, damn, that's what I was supposed to do? And then, hopefully, begin to move the block into the goal more often. Next, I had to set up a multi-agent system so I could train the AI 12 times faster. Essentially what this does is every copy of the agent will do its training individually, but it uses what every other instance of the agents learned, allowing for me to speed up the training immensely. Essentially, the agents now have the ability to read each other's minds and use what everyone learns to get smarter. Now it was time for the scary part. Running my laptop for about 8 hours while I slept and seeing how well the agents turned out. broke after 20 minutes. Okay, well, maybe broke isn't quite the right word. The little guys decided that standing still was the best way to get their reward. Of course it wasn't, but they didn't know that. All they could figure out was that being somewhat near the block would get them a slight reward, and since they never managed to get the block into the goal, they decided that standing near the block was the only way to get a reward. It was time to lock in. The first step was to lobotomize the agents and restart their training with slightly different positive rewards, which would discourage standing still. While fixing this, I noticed some other small issues with my agent code, such as the fact that I never actually set up the code which detects when the block enters the goal, which means that even if the agents did manage to push the block into the goal, it wouldn't have been detected. Then I quintupled the reward that I gave the agents for pushing the block in the right direction and doubled the size of the blocks themselves in order to make them easier for the agents to push. So then I ran the training again, and this time they kinda worked. Granted, my code isn't perfect, and I didn't have time to train them for nearly as long as is ideal, but they still sort of worked, which I consider to be a win. Unfortunately, as much as I would love to improve this AI more and more and keep upgrading it until it can push the block perfectly every time, I just don't have the time right now. This project is due in 4 days, and I still need to make the video that I'm turning in. That's this video, by the way. So with that said, this project has taught me so much about the inner workings of artificial intelligence and machine learning, and has piqued my interest to continue learning more about this fascinating area of computer science. So maybe sometime in the future I might return to this project or one of a similar nature. But for now, that's all I have for you.